In today's video, we will be looking at writing verbal expressions as algebraic expressions. This is basically going to be a review of your knowledge of the various words that mean add, subtract, multiply, and divide. What we have in front of us are 10 verbal expressions. A verbal expression is one that's written out using words instead of symbols. And our job is to write algebraic expressions, symbols and numbers. First problem asks us to write 5 times 10. And I hope that you are familiar with 3 different ways to do this. The first, 5 times 10, using the multiplication x. The second is 5 times 10 using the multiplication dot. And the third, that I do hope you are familiar with, is 5 times 10 by using parentheses to show multiplication. Now, 2 of these we don't really use moving forward into pre-algebra. The first that we do not use is the 5 times 10 with a multiplication x. That x will very soon be confused with the letter x. So we want to get out of that habit. And I want to be clear, I'm not saying that we will never use x as a multiplication symbol again. We'll actually do so in a couple of days with our exponents when we get there. But it's like all rules. Unless we know we're allowed to break that rule, we want to follow it. So in general, we do not want to use an x to show multiplication anymore. We also don't want to use the dot. This is purely stylistic and neatness related. Students have a tendency to not be the neatest writers, and I have seen many times students mistake multiplication dots for decimal points. And the easiest way to avoid that is just simply to not use the multiplication dot. So moving forward, we are going to make a point of using parentheses when needed to show multiplication. The second example introduces some algebra. We have a letter, a variable, the product of x and 5. So this requires you to know what the word product means. Product tells us to multiply. So you might be thinking, okay, the product of x and 5, if I'm going to use these parentheses that Mr. Noy insists that I use, should be written as x times 5. And actually, hold on one second. I want that in my purple. And some more of you may be thinking, well, it's multiplication, the order doesn't really matter, so I could instead do this. And both of these show the idea of x times 5, but both of these are unacceptable mathematically. Mathematicians want to write things as simply as possible and with as little writing as possible. The less you have to write, the less chance of mistake there is. That's not to say we don't show our work. You should always show your work. But mathematicians have agreed that the product of 5 and x is to be written 5x. There is no symbol between the 5 and the x. There are times in mathematics where things are allowed to be invisible. And when we are multiplying a number such as 5 and a variable such as x, multiplication is allowed to be invisible. But they must be written in this order, 5x. We are not allowed to reverse that. Okay? If you show a mathematician x5, they're going to be a little confused. It's just not the order in which this expression is written. And whether we like it or not, we do have to work with these established conventions that have been around for a very, very long time. So the product of a number and a variable will always be written in this format of number letter. Third example, we have 70 divided by 7. Most of you are probably thinking 70 divided by 7. Division symbol, cool. Some of you might be thinking long division, and both of these do say 70 divided by 7. But again, for pre-algebra, we aren't going to use these. Now, I'm not saying you'll never see them. You'll see the long division symbol pop up again in a couple of weeks, months, when we get to decimals. And you'll see the division symbol itself in a couple of lessons when we start talking about the order of operations. However, as we move through this year, we're going to do our very best to move to the idea of representing division with a fraction bar. So 70 divided by 7 is going to be represented as 70 over 7. And this is how we're going to write division this year. I will take a partial point off if you use the division symbol. Same thing on the product of x and 5. If you write it in one of the ways I crossed off, I will not take all the points for the problem off, but I would take partial credit off. Okay? I'm trying to get you into the habits you will need to be in for the successful study of Algebra 1 and geometry and whatever maths you happen to go on to from there. So please pay attention to these little details. They're small, but important. Fourth example, we have the sum of m and 8. So we need to know what sum means. Sum is telling us the addition of two things. So the sum of m and 8 is m plus 8. But sum doesn't really imply an order. Because if you add two things, it doesn't matter if you add like 2 plus 4 or 4 plus 2. You get 6. So when we say the sum of two things, we're actually allowed to pick what order we put them in. Don't get used to this. Sum is a rare example. Our fifth example of the day, 9 plus a number, not 5, 9 plus a number. We don't know what the number is. If it helps, finish the statement by saying 9 plus a number x. So we give the number a name. We don't know it. It's a variable. So we're going to call it by any letter we want. Generally, we use x if we don't have a specific thing to use. So 9 plus the number x. 9 plus x. Now, some of you might be thinking, hey, we just said above that addition doesn't care about the order. That means it's what we call commutative. So can I write x plus 9? No. This specifically said 9 plus the number x. We must write it in the order that it's told to us. 6 more than a. 6 more than a. This implies the fact that we're going to start with a, and more than means we're going to add on to it the 6. Again, this verbal description tells us very specifically we must do a plus 6. 6 plus a, while the same ultimate fact, is not coming from the verbal expression 6 more than a. And we have to be true to the verbal expression. Our seventh example, 7 times 10. Again, remembering that we're using parentheses to show multiplication. In number 8, a number plus 7. Again, if we see the phrase a number, that just means pick a letter. And if I'm going to pick a letter, I'm always going to pick x. So a number plus 7 is x plus 7. The only operation we haven't seen yet, and the target of our last two examples, is subtraction. The difference of 12 and 6. Difference is a keyword that implies to subtract. So the difference of 12 and 6 is 12 minus 6. And think about that for a second. The difference of 12 and 6, what's between 12 and 6? Well, we know that's 6, and 12 minus 6 is 6. Could you reverse this and say 6 minus 12? No. Subtraction is not reversible. If you try to switch subtraction around, you will change the sign of your answer from a positive number to a negative number. And while we are going to deal with negative numbers this year, we're not there yet. So the difference of 12 and 6 is 12 minus 6. And the final example of 20 less than n, this goes back to looking like number 6. Less than, more than. These types of problems tell us start with the second thing in the problem. So n. Then we decide addition, subtraction, what have you. In number 6, more than told us addition. In number 10, less than tells us subtraction. And how much less than n are we supposed to show? 20 less than n. So we put down our 20 for the statement n minus 20.